Question 12, Part B. In a chemical reaction, a compound X is formed from a compound Y. The mass in grams of X and Y are X of T and Y of T respectively, where T is the time in seconds after the start of the chemical reaction. Throughout the reaction, the sum of the two masses is 500 grams. At any time T, the rate at which the mass of compound X is increasing is proportional to the mass of compound Y. At the start of the chemical reaction, X equals 0 and dx dt equals 2. Part 1. Show that dx dt equals 0.004 times 500 minus x in brackets. The first detail that we're given is that the sum of the masses of the two compounds is always equal to 500 grams at any point in time. So we can set up an equation to reflect this. X plus y is equal to 500. Rearranging this equation to make y the subject, we get y is equal to 500 minus x. Now we're also told that the rate of change of the mass of compound X with respect to time is proportional to the mass of compound Y. And we can set up a differential equation to reflect this. We get dx dt, so that's the rate of change of X with respect to time, is equal to k times y, where k is the constant of variation or the constant of proportionality. Now y is equal to 500 minus x, so dx dt can be expressed in terms of x. We get dx dt is equal to k times 500 minus x in brackets. Now we need to apply the boundary condition, that is dx dt equals 2 when x equals 0, to find the value of k. So substituting 2 for dx dt here and 0 for x here, we get 2 is equal to k times 500 minus 0. So that's 2 equals 500k. And dividing both sides of the equation by 500 to make k the subject, we get k is equal to 2 over 500, which equals 0.004 in decimal. Therefore, dx dt is equal to 0.004 times 500 minus x in brackets as required. Part 2. Show that x equals 500 minus a e to the power of negative 0.004 t satisfies the equation in part 1, and find the value of a. Starting with the equation x equals 500 minus a e to the power of negative 0.004 t, differentiate x with respect to t using the chain rule. And we get dx dt is equal to 0.004 times a times e to the power of negative 0.004 t. Now rearranging this equation to make a e to the power of negative 0.004 t the subject, we get a e to the power of negative 0.004 t equals 500 minus x. So we can replace this part of the derivative from the a onwards with 500 minus x in brackets. Hence dx dt equals 0.004 times 500 minus x in brackets, which is identical to the differential equation in part 1. So x equals 500 minus a e to the power of negative 0.004 t satisfies the equation in part 1. Now to find the value of a, and we need a boundary condition for that. We know that at the start of the reaction, that is when time t equals 0, x is equal to 0. So substituting t equals 0 and x equals 0 into this equation here, we can then proceed to solve for a. So 0 equals 500 minus a e to the power of negative 0.004 times 0, which of course is 0. We get 0 is equal to 500 minus a times e to the power of 0, and e to the power of 0 is equal to 1. And that brings us to 0 equals 500 minus a, therefore a is equal to 500.